In this video, we're going to be talking about an introduction to SOHCAH TOA. And SOHCAH TOA is just an acronym that's going to help us understand how to find different sides and angles in right triangles. So if you look at the top of our screen, I've written down what each letter stands for in our acronym. So SO stands for sine of an angle is equal to opposite over hypotenuse. CA stands for cosine of an angle is equal to adjacent over hypotenuse. And TOA stands for tangent of an angle is equal to opposite over adjacent, and that's going to make more sense once we actually jump into example 1. So what we're going to do in this video is just practice writing these three trig ratios for different angles in our right triangle. And what's important to note is that SOHCAH TOA is only used for right triangles. You can't use it on other types of triangles. So if we take a look at example 1, we have this right triangle, and I've labeled the sides and angles. So what we're going to do is we're going to find the sine, cosine, and tangent of angles A and C. We typically are not finding the sine, cosine, and tangent of the right angle. So over here, I'm going to write angle A. And what I want to do first is figure out what the opposite and adjacent sides are for angle A and our hypotenuse, which is always going to be the side across from the right angle. So in this case, it's 5 inches. So we're just going to write down what all of the sides are for angle A. So first, let's figure out what the opposite side is. So when we're determining the side opposite, we have to understand what angle we are looking at. So we're looking at angle A. So the side opposite of angle A is right across from angle A. So this 3-inch side is opposite of angle A. Our adjacent side is the other leg. So the leg that actually makes up angle A. So this leg, along with the hypotenuse, makes up angle A. So that's the adjacent side for angle A is 4 inches. And our hypotenuse is always across from the right angle. It is the longest side. So our hypotenuse is 5 inches. And now we're going to find the sine, cosine, and tangent of angle A. So the sine of angle A is equal to our opposite side, and that's going to be over our hypotenuse. And we know that the side opposite of angle A is 3 inches, and our hypotenuse is 5 inches. So we get that the sine of angle A is 3/5. We're going to do the same thing for the cosine. So the cosine of A is equal to the adjacent side over our hypotenuse. We know that the side adjacent to angle A is 4 inches, so we're just going to put 4. And we know our hypotenuse is 5, so the cosine of angle A is 4/5. And finally, to find the tangent of angle A, we need to put our opposite side over our adjacent side. And we know our opposite side is 3 inches, and our adjacent side is 4 inches. So we get that the tangent of angle A is 3/4. And now what I want to show you guys is that we can also evaluate the sine, cosine, and tangent of the other non-right angle in this triangle. So we can do the same thing for angle C, and you're going to see how these values are related for angles C and angles A. So I'm going to erase this line here really quickly. And now what we want to do is figure out what the opposite and adjacent sides are for angle C, because they're going to be different than they were for angle A. So if we take a look at angle C, the side opposite of angle C is going to be this blue side, the one that measures 4 inches. So this time our opposite side is 4 inches. Our adjacent side is the other leg. So the adjacent side is the leg measuring 3 inches. And the hypotenuse stays the same. So our hypotenuse is still 5 inches. And now we're going to do the same thing. We're going to find the sine, cosine, and tangent of angle C. So the sine of angle C is equal to the opposite side, which this time is our blue side, over our hypotenuse. And in this case, the opposite side from angle C is 4 inches, and the hypotenuse is 5 inches. The cosine of angle C is equal to the adjacent side over the hypotenuse. And we know that our adjacent side is 3 inches in this case, so we're going to put 3, and our hypotenuse is still 5, so we're going to put over 5. And finally, the tangent of angle C is equal to the opposite side over the adjacent, and our opposite side of angle C is 4 inches, and the adjacent side to angle C is 3 inches. So we get that the tangent of C is equal to 4/3. And now I want you guys to see if you can figure out any relationship between the sine, cosine, and tangent of angle A and the sine, cosine, and tangent of angle C. And if you take a look, you may notice that the sine of angle A is equal to the cosine of angle C, and you can tell by the colors as well. And you also may notice that the cosine of angle A is equal to the sine of angle C. So this is always going to be true in a right triangle. The sine of one of the non-90 degree angles is always going to be equal to the cosine of the other non-90 degree angle, and vice versa. And then if you look at the tangents, you may notice that they're reciprocals. So the tangent of angle A is 3/4, and the tangent of angle C is just that fraction flipped upside down, which is 4/3. And again, this is always going to be true as well. So hopefully this video helped you guys understand how to use SOHCAHTOA a little bit better. If you guys want to learn how to actually apply this acronym and this rule to finding sides and angles in a triangle, you should check out our other video, which teaches us how to find missing sides and angles in right triangles using SOHCAHTOA.